Question 4. Consider the expansion of x squared plus 2 over x to the power of 10. Write down the number of terms of this expansion. According to this binomial theorem, for a plus b to the nth power, we have n plus 1 terms. So for 4a, 10 plus 1 equals 11 terms. For b, find the coefficient of x to the eighth power. X squared plus 2 times x to the negative first power to the power of 10. The general term is this, n equals 10. So we have 10 choose r times. This is a, this is b. X squared to the power of 10 minus r times 2x to the negative first power to the power of r. Simplify 10 choose r times x distributive property 20 minus 2r times 2 to the r's power times x to the negative r's power. We will put coefficient first. 10 choose r times 2 to the r's power. Multiplication of a power, we add exponents. So x to the 20 minus 3r's power. We are looking for the coefficient of x to the 8th power, which means 20 minus 3r equals 8. Solve this. 20 minus 8 equals 3r. 12 equals 3r, so r equals 4, which means the coefficient of x to the 8th power will be this. 10 choose 4 times 2 to the 4th power equals. Go to calculator. Menu 5 probability combination. 10, 4 times 2 to the 4th power. Enter. Answer is 3360. 3360 is the coefficient of x to the 8th power. Let's go to question 5. Consider the expansion 2 plus x to the nth power, where n is greater than or equal to 3, n is integers. The coefficient of x third power is 4 times the coefficient of x squared. Find the value of n. We will use this formula because this n is a positive integers. 2 plus x to the nth power. General form is here. N choose r times. This is a, this is b. 2 to the n minus r's power times x to the r's power. We do know 1 r equals 3. The coefficient is n choose 3 times 2 to the n minus 3rd power. When r equals 2, n choose 2 times 2 to the n minus 2th power. Based on the given information, we can set up the equation. N choose 3 times 2 to the n minus 3rd power equals 4 times n to the 2 times 2 to the n minus second power. Now we will change combination into algebraic form. N times n minus 1 times n minus 2 over 3 factorial times 2 to the nth power times 2 to the negative third power equals 4 is 2 squared times n times n minus 1 over 2 factorial times 2 to the nth power times 2 to the negative second power. Let's simplify. N times n minus 1 and 2 to the nth power, 2 to the nth power. So we get n minus 2 over 3 factorial is 6 times 2 to the negative third power is 1 over 8. 2 squared, and here 2 to the negative second power is 1. So we got 1 over 2. Then times 48 both sides. So we get rid of this 6 and 8. N minus 2 equals 24. N equals 26. Let's go to question 6. Consider the expansion 3x squared minus k over x to the 9th power, where k greater than 0. The coefficient of the term x to the 6th power is this. Find the value of k. Since this n is positive integers, we will use this binomial theorem. General form is this. 3x squared minus k times x to the negative first power to the power of 9. General form. N equals 9. 9 choose R times A is 3x squared. B is negative k x to the negative first power. 3x squared to the 9 minus r's power times negative k times x to the negative first power to the power of r. Put coefficient together. 9 choose r times 3 to the 9 minus r's power times x to the 2, we will do the distributive property, 18 minus 2r times negative k to the r's power times x to the negative r's power equals 9 choose r times 3 to the 9 minus r's power times negative k to the r's power times x. We will add the exponents, 18 minus 3r. We know the coefficient of x to the 6th power is 6048. This is the exponents of x. We will set up 18 minus 3r equals 6. R equals 4. So this coefficient is 6048. Now we plug in r equals 4 to this coefficient. 9 choose 4 times 3 to the 9 minus 4th power times negative k to the 4th power. Simplify. 9 to the 4 times 3 to the 5th power times k to the 4th power equals 6048. Manual 5. 3 combination 9, 4. Enter. 126 times 3 to the 5th power times k to the 4th power equals 6048. Control menu. Enter, enter, enter. Menu 2, enter. 2 over 3. By solver, k equals 2 over 3.